do you mind if I make an announcement?
Yeah, of course. Okay, can make an announcement. Hello everyone, so your SI class leader Riley wants to make an announcement, so listen up.
Hi everyone, I just want to let you know that on my session on Tuesday, if any of you attend, at the very end a tutor will come in to talk about what tutoring is about. So if you guys want to attend my session and then come listen to the tutor talk to get more information about that, please come. Thank you.
Okay. So, any questions? Okay, before I start the lecture, does any of you have any questions about the homework or anything in the class? Everything is clear? Okay. So, these are, I know that I have this slide like over and over again, but still some of you are struggling with the concepts. So I keep having this slide to make sure everyone knows what is an element, what is a compound, and can anyone tell me? And the other thing I want to mention is like class participation. As I told you guys, when I going to give you like the final grade in this class, and then you receive like 89. So as we progress with the lectures, I kind of like learn your names. So if I saw someone that got 89 and I realized that they had class participation, I'm going to give them 90. So I encourage you to have the class participation in case, you lack like 1 or 2 points, and based on class participation, I will give, I will add points to you. Does that make sense? So that being said, can anyone tell me what is an element? Yes? Exactly. So your friend, I realized that she always, tells a definition of element every session. So all of you at this point should know what is an element, okay? And where can I find elements? If I want to name elements and I don't know all of them off the top of my head, where should I refer to see the name of the elements? Exactly. So can anyone tell me what are, element symbols, or like how scientists came up with that?
They are abbreviations of either English words or Greek words, is that what you said?
Uh-huh.
Or they lack.
Okay. So what did you want to say?
Me?
Yes.
Oh, I was just going to answer the previous question.
Okay. So can anyone tell me, so one of them was like English names, right? Like for instance, beryllium is like BE, right? Or some of them are like based on the Latin or Greek names, like potassium, which is K. So what are some other ones that, yes?
Named after certain countries.
Exactly, name of some countries, like France. Great, so what else?
Scientists.
Exactly, like the name of scientists, right? Or some of them based on the properties that a certain element had, like argon, right? And I gave you so many questions in homework 7 that I posted yesterday. I finished writing all of them yesterday, and all the questions. And you should know periodic table really well. I mean, you have the periodic table in front of you, and that is my assumption, that you have this table in front of you, and to answer the questions, you should refer to them, to the periodic table to answer questions. And as you can see, some of the element symbols are really similar. For instance, you have like calcium, it is Ca. You have cobalt, it is Co. You have copper, it is Cu, right? Can you name another element that has C as the first letter in its symbol? Yes, exactly. Carbon, you have chlorine, excellent, right? And then you have like CN here. You know, there are like several of them. Chromium here, Cr. You have like CF here. There are like multiple ones. So when you want to answer homework questions, you should refer to the periodic table. You should know how to read elements' names based on the symbols. And also, if most of the time I gave you the symbol because it was like easier for me to write. And also, you should refer to the periodic table to name, to count the number of protons, electrons, and so forth, so on and so forth. So make sure you know how to work with the periodic table and how to read that. Can anyone tell me how many protons manganese has? Mn. How many? Exactly. So this is the atomic number. Remember, this is number of protons. And if an atom is neutral, the number of protons equals number of neutrons. Okay? So if I ask you how many electrons manganese has, electrons, what would be the answer? 25, right? But if I ask you, and I have like this slide to review ions as well, but if I tell you manganese 2+, how many protons it has, what do you say? How many protons? Okay, so this is good that I'm asking the question so I know what are the, difficulties the students are facing. So if you just look at the periodic table, you see, Mn, and then you see 25. Remember, number of protons in atoms doesn't change, except like nuclear reactions and all that we're not going to talk about in this class. Protons do not participate in chemical reactions. So anytime that I ask you how many protons this ion or element has, you simply go to the periodic table, look at atomic number, and report that as the number of protons. So Mn, although number of electrons is different here, still it has 25 protons. This number that we write here, this charge, it relates to the number of electrons, not protons. Okay? But when you want to write number of electrons for Mn2+, you know that, manganese is a metal, right? So metals lose electrons. Plus, you see here we have like positive charge. And these two, it means that how many electrons manganese has lost. So manganese, Mn element, or Mn, I guess I write Mn atom, has 25 protons, okay? And Mn2+ was Mn atom that lost 2 electrons. Writing that, giving you this explanation. Now, can you tell me how many electrons Mn2+ has? 23, right? Because Mn itself had like 25 protons, 25 electrons, right? And now it has lost 2 electrons. So still it has 25 protons. Again, number of protons don't change. And it has lost 2 electrons. So now it has 23 electrons. Is that clear? Any questions? Okay. So if there is no question, I'm going to go back to the periodic table and I try to, okay. On one hand, I want you guys, if you're writing, still, write. On the other hand, I want to show this. And I'm going to post everything that I write after the class on Canvas in the PowerPoint, so don't worry if you missed writing something. Okay, so we talked about, group 1A, 2A, 3A, 4A, and now I want to add some elements. If you were progressing, if you remember the things that I taught you previously, I asked you to remember carbon, silicon, germanium, right? Now I want to add tin and lead to the list. So remember that these elements are in group 4A, okay? And can anyone tell me what was specific about like these groups or families? Or like what characteristics each element in each group has? Or like what is specific about like groups or families compared with rows or periods? Yes?
Letters or non-letters?
Yes, so basically group 1A, 2A, except hydrogen, group 1A, 2A are like metals, and then, in group 3A, 4A, you have, I encourage you again, if you know carbon, silicon, germanium, tin, lead, when I ask you quiz questions, you can answer them, much rapidly, and then, you learn better. Okay. No questions? Like, combination of like metals, metalloids, non-metals, and then in these groups, like 8A, mostly you have like noble gases, you have gases, you have halogens. So in general, each group or family elements which are, I guess, in the same group of family, they have like the same properties. So this helps us that if I give you like fluorine or chlorine, you know that they are halogens, and some of the groups have group names. Remember? For instance, here, okay. And the other thing that I asked you in the homework 7 is like, as I said, there are lots of elements that they have like similar abbreviations. For instance, if you just consider boron, it's like metalloid, right? Remember metalloid, that they were like, they had like some properties of metals, some properties of non-metals, and remember? And usually they were like in this zigzag kind of, I don't want to mess up the periodic table, but you see, if you kind of like consider these like purple color elements here, they kind of form a zigzag here, right? So boron, silicon, germanium, arsenic, and antimony, tellurium, astatine. These are metalloids. And I asked several questions in your homework, which of the following is a metalloid? And then I asked you B, BR, BE, BA, and then if you look at it, look at the periodic table, you find more B elements that start with B. So these can be, several of them. So pay attention. And as I said, if you learned boron already that I talked about, B, boron is group 3A, is metalloid, right? So the other thing with like Si, silicon, right? You have Si, you have Sc, you have like several elements that start with S. S itself, sulfur. So, practice the periodic table, just like, look at like these different periodic tables that I posted, so you know how to answer quiz or like homework questions. Okay? Any questions so far? Are we good with the materials that we learned last class? What I was, okay. Can anyone tell me what is the charge of one proton? +1, right? Or 1+. What about an electron? Exactly, -1 or like -1 or like 1-, right? What about neutron? 0, right? And these things, when I asked during the class, it seems like easy, but believe me, lots of you, make mistakes in the homeworks or like exams because you don't pay attention or you didn't learn well. So remember, protons, they have charge of +1 or like 1 proton. 1 electron has charge of -1, and neutrons are neutral. So they don't have any charge, it's 0. And mass of 1 proton is roughly 1 atomic mass unit, and neutron also roughly 1 atomic mass unit. And then electrons are really, really light. They are almost, 0. They are really light. So most of the mass of an atom is because of protons and neutrons. Okay? And also, can anyone tell me if I have like an electron and proton, so they have like opposite charges, do they attract each other or repel each other? Attract each other, right? But if I have negative or positive charges, they repel each other, right? So also remember this. And if I have like 1 positive and 1 negative charge, they cancel each other. If you add them, it becomes 0. Here, mass of each proton and neutron is like roughly 1. So when we even add those numbers, the mass of the element would be almost the same as mass number. Does that make sense? So if you have like 1 proton and 0 neutrons, the mass number would be 1, and atomic mass would be 1.0073. So if you round the numbers, they are basically the same. For that matter, in most of the calculations that we do in this course, or like most questions that you encounter, mass number and atomic mass are basically the same, because they just differ like digits, after decimal point, the difference would be like really small. So for that matter, mass number and atomic mass for an element are all, and we have like, back to the other thing that we learned that I'm going to emphasize, because I asked you several questions in the homework, I asked you that which of the following is not a transition element. And then, so looking here, I asked you, I tell you which of the following is not a transition element. And I say CO, CR, CU, CL. Which one is not a transition element? CL, right? So remember, elements that you have here, these are your transition elements. They have like letter B with a number, right? So if I tell you one element belongs to group 1B, it's a transition element. But main groups, they have like a letter A with a number. And then basically 1A, 2A, 3A till 8A. Okay? Are we good with these concepts? Any questions? Okay. Or the same. Does that make sense? And the other thing that students confuse during answering questions is like periodic table that Mendeleev had, and also the modern periodic table. So remember, the modern periodic table that you see in this classroom and also in your book is sorted based on atomic number. Atomic number of hydrogen is 1, atomic number of helium is 2, lithium 3, and so on, right? So it's sorted based on increasing atomic number or increasing number of protons. But the periodic table that Mendeleev came up with was sorted based on relative mass of elements. And relative mass is mainly number of protons and neutrons. So, kind of distinguish these two things. I tend to ask them during the exams, and most of the time the student confuse those. So remember, Mendeleev worked with mass, but the modern periodic table is sorted based on atomic number of protons. The other thing is that the early version of periodic table that Mendeleev had, it had like few elements. But the modern periodic table is like, it consists of more elements because more elements have been discovered since him. Okay? And again, I added these two sentences here. And everything that I include here is from your book, as I mentioned at the first slide too. So you don't confuse them. Any questions? As unit here, okay. Group 1A, we call them alkali metals. Group 2A, we call them alkaline earth. And then 7A, halogens, 8A, noble gases. So families or groups, they have like the same similarities, the same properties. Okay, so this is kind of what distinguishes them from like rows or periods. So I may give you like as a true or false in the homework problem that elements in the same period have the same properties. So this sentence would be false, right? And as your friend mentioned, for instance, if we are like in group 1A, we have, except hydrogen, we have metals, and they are reactive metals. Or like group 7A, we have like halogens, and they are reactive non-metals. And I asked that as true or false in like last semester. Most students, when they just see reactive, I was saying, is the following statement true or false? Elements in group 7A, basically halogens, are reactive metals. And sometimes the students just see the word reactive and they think that the sentence is correct, but just read the question really well, okay? Okay, and then we talked about this. Remember, group 1A is alkali metals, group 2A is alkaline earth. What is group 7A? What is the group name? Halogens, right? And group 8A is noble gases. So now if I ask you which of the following is not a noble gas? Hydrogen, helium, neon, argon. Hydrogen, right? Hydrogen belongs to group 1A. It's not an alkali metal, it's not a metal, but it's really reactive and it's in group 1A. Or if I ask you which of the following is not a halogen? B, Br, Cl, I. B, right? And most of the time the students confuse boron with bromine. So make sure that you know the differences. And again, if you learn the elements each session, when I'm teaching them and memorize them, it helps you for the homework assignments and exams. Finally, which of the following is not a transition metal? Ru, I write them, Ru, Re, Rh, and Ra. Ra, right? So Ra is an alkaline earth metal, but Rh, Ru, Re, which is here, these are transition elements. So again, you need to practice periodic table to know the abbreviations, and I'm going to give you periodic table in the exam, so you don't have to worry about it. But sometimes I ask which of the following is not a metalloid or which one is metalloid, and the version of the periodic table that you see in the exam would be black and white, and it doesn't have like explanations. So you should know how to read it or practice enough to be able to answer questions in the exam. Any questions? Good. Okay. Now I'm going to continue to talk about ions, and we talked about these last session, but because I want to make sure you know these concepts well, I kind of like included a slide of summary of what I talked about before. And can anyone tell me what is an ion?
Particles that have lost or gained electrons.
Exactly. So as we said, in the chemical reactions, atoms lose or gain electrons. So we work with electrons. So your nucleus is intact. We don't do anything with the nucleus. Remember, the protons and neutrons are the same, except we have like nuclear reactions and all that. As I mentioned, we're not talking about them in this class. So in this course, in our class, electrons participate in reactions. Okay, and if an atom loses an electron or electrons, what do we call that specific element that has lost electrons? Okay. Which one? Anion or cation? Cation. Remember. So, positively charged ions such as Li plus, lithium plus are cations, right? So, if atoms lose electrons, they gain, or like they become positively charged. So they become cations. Okay, and which categories of elements usually lose electrons? Metals, right? Remember that was one of the characteristics of metals, or kind of like their definition basically, that they tend to lose electrons. They're like mostly metals. What about gaining electrons? If we have like an element that gains electron, what do we call that specific atom that gains electrons? What is it? Anions, exactly. So I'm going to write that, I guess, with green. So if they gain electrons, become negatively charged, and we call them anions. Sometimes, I tell you like which of the following is correct, and then I tell you that Mg2 plus is a cation. Is this correct or incorrect? This is correct, right? Because it has positive charge. But if I tell you Mg2 plus is an anion, that would be false, right? Okay, are we good with like cations, anions, charged particles, and all that? Okay. Now this is like the new topic that I'm introducing this session. So now we want to talk about isotopes. And you probably heard that in the news too. Sometimes when we're talking about like radioactive materials, we have like different versions, different isotopes of uranium, for instance. So what are isotopes? So as we talked about, electrons are really light. So the mass of an element is mainly because of its protons and neutrons, right? So what did we call number of protons in an atom? Atomic number, exactly. So what did we call the addition of protons and neutrons here? So, and remember, when I tell you what is number of protons for lithium, what would you tell me? Number of protons for lithium? 3, right? Because the atomic number is 3. And you don't ask me which lithium, because all of them, when you see it in the periodic table, all lithium atoms have like 3 protons. Or like if you look at like chlorine, all chlorine atoms have like 17 protons. That's why we write them in the periodic table, and with confidence we have atomic number of 17. But that is not the case for neutrons. Different atoms of the same element may have different number of neutrons. So that's why we don't write mass numbers for each element. We have like atomic mass that I'm going to talk about in more detail in the next slides, but we have like atomic number. This is just one number because all atoms of a specific element have the same number of protons, but they don't necessarily have the same number of neutrons. Does that make sense? And these are just like what scientists observe and how nature works. So here, again, I included this text to make sure that you also have a reference to refer to, as well as your book and study guide. So, however, they do not necessarily have the same number of neutrons. So I may ask you in the homework, and I say, all chlorine atoms have the same number of neutrons. is the following statement true or false? Is this true or false? That is false. But if I ask you that all chlorine atoms have 17 protons, that is true. Because if they have different number of protons, if you find a Cl atom, or if you argue that a Cl atom has like 16 electrons, that is not chlorine anymore, that is sulfur. Does that make sense? And as we mentioned, neutrons and protons have nearly the same mass. And remember the slide that I showed you previously? They were both of them almost, their mass was 1 atomic mass unit. And we just write the abbreviation instead of atomic mass unit, we write AMU. And remember that is atomic mass unit. So the number of neutrons in the atoms of a given element can vary, as I just mentioned. And because the number of protons is the same, for instance for chlorine, but number of neutrons in different atoms may vary. For that matter, chlorine atoms or chlorine itself in general can have like different, mass numbers, different atoms, because they have like different number of neutrons. Does that make sense? Any questions? Okay, and this definition is really important, and I'm going to keep asking that in your exams or in your exam 2 and final exam. And basically atoms that have the same number of protons but different number of neutrons are isotopes. And that is like the definition. As I mentioned, most of the things that we study, there are like things that scientists agreed to call these things. So we call that isotopes. So atoms that have the same number of protons but different number of neutrons. And the students tend to confuse them in the exam, so you don't get confused. Okay? Same number of protons, different number of neutrons. As I mentioned, if you have like different number of protons, they won't be the same atom, the same element, right? If you have like 17 protons and the other atom has like 16 protons, these won't be the same element, they are different elements. But isotopes are like the same elements. They have the same number of protons but different number of neutrons. Any questions so far? Okay, and not necessarily all elements have isotopes. For instance, beryllium and aluminum, they just have like one number of neutrons. So they don't, the number of neutrons in all beryllium atoms are the same. But for instance, chlorine and neon have like different atoms have like different number of neutrons. So necessarily not all elements have isotopes. Okay? Any questions? Good. In other words, if I have like number of protons plus number of neutrons, what does this quantity represent? Exactly, atomic mass or mass number. So technically that would be mass number because it's number of protons plus number of neutrons. But as we talked about, now, here I have like an example from your book. And also kind of like writing these elements, and then if you want to report mass number of an element along with the atomic number, this is how you write it, that you have like the chemical symbol of the element, right? For instance, you can have like neon. This is like the chemical symbol, right? And here, basically you write on top, you write the mass number, for instance here 280, right? And below you write atomic number. For neon it is 10. So if I give you this in the exam and I ask how many protons, electrons, and neutrons this atom has. Can anyone tell me how many protons? 10, right? Because the atomic number of neon is 10. What about neutrons? How many neutrons it has? How many?
20.
How many of you say 20? How many say 10? Okay, remember, this is like the mass number, and mass number was like number of protons plus number of neutrons, okay? So when you have like this number here, that is number of protons plus number of neutrons. So here we said that we have 10 protons, right? So you have 20 minus 10, which gives you number of neutrons, okay? Is that clear? So how many electrons? 10. Why 10?
Same number of photons.
Exactly. So if you just have an element, a neutral atom, number of protons equals number of protons equals number of electrons. Okay? Because the atom is neutral. If they have charge, you should do like more calculations to see number of electrons. Okay? Any questions? So here, let's do like some examples. So if and the other way to write these elements with their mass numbers is that you write the chemical symbol of the element, or like atomic symbol rather. So for instance, here you can write neon dash and then mass number 20. If I give you this in the exam, I expect you to know that you can refer to the periodic table and see neon has like 10 as its atomic number, so it has 10 protons. And here you have like the mass, so you can deduct 10 from 20 and get 10 neutrons if I ask you the number of neutrons, okay? Is that clear? Any questions? Okay. And the other thing about isotopes is that we can have like, or if we have like neon in this case, as we said, number of protons in all of them is the same, but number of neutrons may vary. And in case of neon, we have some atoms that they have like 10 neutrons, some atoms that have 11, some atoms that have 12. And we also have like different number of them. So we have like percent natural abundance. So basically, scientists like kind of measured these things and came up with these numbers based on the experiments that they did, or like observations that they did in nature, from nature, that 90.48% of neon atoms in nature have 10 neutrons. And 0.27% have 11 neutrons, and then 9.25% have like 12 neutrons. So almost 90% of neon atoms that exist, they are neon 20. And then 0.27, almost 0.3% of neon atoms are like neon 21, and 9% almost, they are like neon 22. And you don't have to memorize these numbers, or like number of number of neutrons or protons for that matter. Number of protons, I give you the periodic table, so easily you can know the number of protons, right? And then number of neutrons and then their abundance, I'm going to give you in the exam. Okay, but you should know that some of the isotopes can be found more easily, or like they are more abundant in nature. Some of them are like more rare. So in this case, neon 21, is like really rare. You can see how small this number is. So from like 100, this is kind of like percentage, right? From like 100 neon atoms in nature, almost 90 of them are like neon 20, right? It's like 90% almost. And then 9% almost, they are like neon 22. And then less than 1%, basically, the chances of you finding neon 21 is like really low. Does that make sense? Any questions about this? Yes?
Is neon 20 still considered, that's not considered an isotope, or is it just 21 and 22?
All of them are isotopes, but neon 21 is just like more rare to be found, but it still exists. Great question. Any other questions? Good. For like different isotopes that we have, there are like different probability for us to find them in nature, right? So if I want to report mass of neon, right? And then I want to report what is atomic mass of one neon atom. How do you think that we should report that? Considering it can be different, right? It can have different number of neutrons and their abundance is different. So if I want to just report one single number for atomic mass of neon, what should I do?
Take the average.
Exactly, take the average, right? So it's like 90.48%. It means that from every 100, there are like 90.48 would be like neon 20. So I can write this number as 0.9048, right? These two numbers are the same. And I just write it as a fraction so I can do the calculation. Does that make sense? Okay, the other concept that we're going to talk about is like atomic mass. So as I just showed you here, what we do is that we have like, the mass of isotopes, right? In the previous table, we also were given like different masses of different isotopes. So we have like mass of isotope 1, we multiply that by fraction of isotope 1. It basically is abundance. So here, so that would be fraction of isotope 1 multiplied by mass of isotope 1 plus fraction of isotope 2 multiplied by mass of isotope 2 plus fraction of isotope 3 multiplied by mass of isotope 3 plus, if you have like more isotope, you just keep writing this. And above, I have like the same formula, it's just like in one line. So I thought to just also include that, so in case there is any confusion. Any questions so far? Yes?
Is this sort of thing going to be on our homework?
What's that?
Is this going to be on the homework?
Not this homework. So the homework, I wrote that during the weekend. So everything that you learned till last Friday is on homework. So technically you could have answered the homework questions yesterday too. But these would be on your next homework for next week. So you have more time to practice. Great question, thank you. Any other questions? Okay, if no more questions, let's do an example of these. So, okay. I'm going to write an example from your book, which is example 4.9. Gallium has two naturally occurring isotopes. One of them is gallium 69 with mass of 68.9256 atomic mass unit with the natural abundance of of 60.11%. The other one is gallium 71 with mass of 70.0 0.9247 atomic mass unit and a natural abundance of 39.89%. Now you are asked to write atomic mass of gallium. And considering the formula that we have here, can anyone guide me to write this solution? So what is atomic mass? So you have two different isotopes. One of them, it has mass of 68.9256 atomic mass unit, basically gallium-69. The other has mass of 70.9247 atomic mass unit. And you were given the abundance too for each of them, right? So how would you write this? Basically, you substitute in this equation, right? So what is mass of isotope 1?
68.9256.
Exactly, 68.9256. Multiply by what is fraction of isotope 1? 60.11 divided by 100, right? Is that clear? Any questions so far? Plus, now, what is mass of the second isotope? 9274. What is its fraction? Exactly, 69.89 divided by 100, right? Is this clear how we wrote this? Right? So when you put this in the calculator, you get 69.72 atomic mass unit. Or like before that, you get 69.7231, and then you can round it to write 69.72 atomic mass unit. And remember, again, it's kind of like taking an average, right? If you're taking average of 20 and 10, your answer should be within that range, right? Even if you have like different weights for each of like these numbers, right? If I tell 10 students in the class they got like 80, and then 20 students got 90, right? The average still would be between those two numbers. Does that make sense? But like we have like different number of students, so that is basically your abundance. So here again, your number should be between these two numbers. So if you solve this problem and then you get a number that is not within the range, you did something wrong, okay? Any questions? So you're doing the attendance. I just tell you that I finished chapter 4. So probably next session I'm going to solve more examples for you guys, but it would be like limited few examples. So I encourage you to go to your SI Pass leaders because they're going to help you with your homeworks and with like these concepts that we learned. And if you have any questions from chapters 1 to 4, specifically about the elements or significant digits, I know that most of you still have difficulty with those, but you're not going to see significant digits anymore. You still need to know how to round numbers, but rounding and significant digits would be like 2 or 3 questions in your final. You're not going to see them anymore. But elements and like these concepts, convergent fragments, if you have difficulty with those, you're going to suffer during the class. So I encourage you to go through chapters 1 to 4. If you have any questions, just ask me so you learn the rest of the chapters.